All right. It's been a fun chapter, but we're reaching the end now. The last one is kind of a fun conceptual question to work through, and we'll just have the fun that it was intended for. So the statement reads, you are asked to referee a grant application which proposes to determine whether the magnetization of iron is due to ampere dipoles or current loops or Gilbert dipoles, separated magnetic monopoles, The experiment will involve a cylinder of iron, radius r and length 10r, uniformly magnetized along the direction of its axis. If the dipoles are ampere type, and the magnetization is equivalent to the surface bound current KB equal M phi hat, then we say if they are Gilbert type, the magnetization is equivalent to the surface monopole densities sigma B equal plus or minus M at the two ends. Okay, so unfortunately, these two configurations produce identical magnetic fields at exterior points. However, the interior fields are radically different in the case that B is in the same general direction as M, whereas in the second, it is roughly opposite to M. The applicant proposes to measure this internal field by carving out small cavities and finding the torque on a tiny compass needle placed inside. Oh, well, we've seen the cavities before, haven't we? So, assuming that the obvious technical difficulties can be overcome and that the question itself is worthy of study, would you advise funding this experiment? If so, what shaped cavity would you recommend? If not, what is wrong with the proposal? All right. So, since we have seen these cavities before, let us use those shapes. So, to move forward, the problem is that the field inside a cavity is not the same as the field in the material itself. So, for A, we see that for ampere type, the field deep inside the magnet is that of a long solenoid. B naught is approximately equal to mu naught M. So, if we see the results from the cavities that we had before, these are the magnetic fields. All right, for a sphere, needle, and wafer. Pretty good, pretty straight there. Now, if they're Gilbert type, this is analogous to the electrical case. And so we'll modify those results with the transcriptions that we saw just a few questions ago in that analogous warfare. So let's modify those and plug them in, and we see we get the fields as such. In the cavities, then, the fields are the same for the two models, and this will be no test at all. So yes, funded.